Hello friends, in this video tutorial, let us see some of the SSIS performance improvement tips. In data flow, we can go to properties and we can set default buffer size or default buffer max rows. This will indicate what is the amount of memory that will be used by data flow task. So if we are having constraint of memory being used by the data flow task, then we can increase the amount of memory available to the data flow task using default buffer size and default buffer max rows. Also, if we want to support multi-threading in data flow tasks, then we can set the property of engine threads. Similarly, if we want to set the multi-threading behavior of control flow, then we can set max concurrent executables. Let us quickly see these properties in Visual Studio. So we are in data flow task. We can set the max buffer size over here. We can increase it if required. We can set the max buffer rows over here, right? And these are the engine threads, which will help us to have behavior of parallel execution in the data flow task. Similarly, in control flow, if you go to properties, then this is a important property, max concurrent executables. With the help of this property, we can support the parallel execution behavior of control flow. Now, in order to have parallel execution within our data flow, we can also use balanced data distribution transformation, as we have seen in one of our earlier video tutorial specifically for this particular transformation, that is balanced data distributor transformation. Also, we can use the concept of SQL Server table partitioning while reading data from the database table to make the process of reading data from the table quite fast. We can employ such strategy, that is having data in partition tables and then reading data from individual partitions, even if it is not a SQL Server database but any other RDBMS like Oracle or MySQL. We can create partitions, we can partition the data in the table, and then we can read in our individual thread, we can read data from individual partitions. That can make the process quite fast. Also, the asynchronous transformations are those transformations which use new memory buffers. That is, they create their own memory buffers for processing the data. Whereas the synchronous transformations are those transformations which do not create their own memory buffers but they reuse the existing memory buffers. Examples of synchronous transformations can be like character map or derived column, and examples of asynchronous transformations can be like sort, then merge, join, union all, aggregation transformation, etc. We can identify whether a particular transformation is synchronous or asynchronous with the help of logging. So we can log our execution at the data flow level using pipeline execution plan and pipeline execution tree properties. If we do this and then if we examine the log, then we will have begin path and end path sections. Each begin path and end path section indicates that separate memory buffers have been created. So with the help of this, we can come to know the behavior of the associated transformation, whether it is creating separate memory buffers or not. So if they are creating separate memory buffers, then they are asynchronous transformations, and we should try to avoid use of asynchronous transformations as far as possible. Also, so there are three types of transformations: fully blocking, semi-blocking and non-blocking. So these fully blocking transformations are those transformations which do not allow data to go ahead. They fully process the data, consume all the data based on the incoming data. They produce the output, and then only data, that is the resultant data, goes to the next transformation or control. So these are very slow in nature. We should try to avoid blocking transformations as far as possible. We should also try to avoid semi-blocking transformations like merge, merge join, union all as far as possible. Non-blocking transformations are fast, are quick, and they do not cause any problems to the performance of the SSIS DTS package, right? So we should try to have only non-blocking transformations as far as possible in our packages. We can identify whether the transformation is fully blocking, semi-blocking or non-blocking again with the help of log. If we go to log and we just enable the property of pipeline component time, and then if we see the generated log, then we can see the prime output filling event. If suppose for a control the prime output filling event is taking time, then it means that it is asynchronous transformation, and most probably it will be semi-blocking or fully blocking. So we should try to avoid such components or transformations. Now we should try to avoid page splits at the time of loading data into a empty or blank table. How can we do that? Let's suppose that the empty or blank table that we have created is having a primary key defined on it. So by default it will have the primary key, which is clustered primary key on a column or a set of columns. So what we can do, we can first of all make the primary key as non-clustered. Then on the same columns which are having primary key defined, on the same columns we can define a separate clustered index. Now when we are trying to load or bulk load data into this table, we can first of all remove the clustered index with the help of execute SQL task, and after the loading is complete, after the bulk loading is complete, we can again use the execute SQL task to recreate the clustered index. In this way we can avoid page splits during bulk load of data in empty or blank tables. Generally we can employ this strategy when we are loading data in our staging tables. Perfmon. You can monitor performance of various performance parameters with the help of perfmon. So let us go to perfmon. So this is the performance monitor. If you go to add counters, you can add multiple counters over here. So one of the important one is physical disk and average disk per second transfer. This is the parameter which indicates how speedy is our input output or IO in the disk. Generally speaking, a value of 0.010, that is 0.010, is considered to be higher value. We should try to have it lower than 0.010 in ideal circumstances, right? Now for any OLEDB connection, go to all tab and packet size and increase the packet size, which may lead to faster network throughput. So let us see where to set this property. Let's say I have got this particular OLEDB connection to the database. So I can double click it, I can go to all, and then I can go to network packet size. So I can change the value over here to increase the packet size. The max value is 32767. To improve the performance of our SSIS package, select only the columns that you need in your data source. So don't bring more columns into our package than what is actually required. To reduce locking from the queries which are extracting data and bringing them to our SSIS package, we can use table hints like no lock or read past while extracting data from database tables. But if you use such hints, then the query results may be different, right? The actual results that we get from database tables may be slightly different from the results that we obtain without using the table hints, these table hints. So we should be aware about what are the differences that can arise in the data and then only use these table hints in order to avoid locking. For lookups, you can use shared lookup cache, which can improve the performance of the lookups. So if we want to use shared lookup cache, then we will have to use cache connection manager and cache transformation. So along with this, if we use shared lookup cache, then it can improve the performance of the lookup. Now we should try to avoid partially blocking and fully blocking transformations like sort, aggregate, merge, merge join, union all. All these five, that is sort, aggregate, merge, merge join and union all, can be accomplished using SQL queries. Like sort can be accomplished by having order by clause in our query, which brings data to our package. Aggregation can be done at the database level itself using SQL queries, because we have got many aggregation functions. With the help of group by, we can aggregate the data. Similarly, merge and merge join can be also achieved through using SQL queries, and union all also can be achieved using SQL queries. So as far as possible, we should try to avoid this kind of fully blocking and semi-blocking transformations, and we should try to replace them with the SQL queries which work at the time of extracting data from the database and bringing the data to the package, SSIS package. So SQL queries are very efficient in performing these tasks as they work within the memory of the SQL Server instance itself. Evaluate if merge can be used in place of SCD in your package. So whatever task is accomplished by SCD transformation, similar task can be accomplished using the merge statement, which is newly introduced in TSQL. So you should evaluate whether we can accomplish our task using merge statement or not. If we can do all the things that we do in SCD with the help of merge, then we should try to use merge because it is very efficient as compared to SCD. Use execute SQL task and insert into instead of copying data from one table to another table without making much of the transformation, and that too in the same instance of the database. So if the data is being transferred from one table to another in the same instance, and that too without making much of the transformation, then over here we can also use execute SQL task, and inside execute SQL task we can write a insert into statement. So all that activity of transferring data from one table to another will happen in the memory of the instance itself, SQL Server instance itself. So which can be very efficient in terms of memory and speed of execution. For incremental loads, generally there is a tendency to remove the or drop the indexes, clustered and non-clustered indexes, then load the data and then recreate those clustered and non-clustered indexes. But we should have caution over here. If the incremental load is very less in terms of percentage of the new data being loaded into the existing table, then we should not drop clustered index. And because the cost of dropping the cluster index, then inserting the data and then recreating the cluster index will be higher as compared to inserting very few records or very less percentage of records into the existing table having clustered index. So if the incremental load is very less in terms of percentage of new data being loaded, then we should not drop clustered index. We should directly load the data that can have better performance results. Also, at the time of incremental data load into a table which has got only single non-clustered index, then we should think of dropping the single non-clustered index only if the data is about 100% of the existing data. The new data, incremental data, is about 100% of the existing data. That is, if the table size is going to double, then only we should think of dropping the single non-clustered index defined on the table. Otherwise, if we can load the data without dropping the single non-clustered index defined on the table. Now, if we are loading data into an existing table which has got multiple non-clustered indexes defined, then it depends on how many indexes have been defined and what are the column combinations of those indexes. Generally speaking, there cannot be a thumb rule defined for this particular situation. But if we just want to generalize a rule, then we can say that if there are multiple non-cluster indexes defined on the table, and if the incremental load is below 10% of the data, existing data, then there is no need to drop the existing indexes. So if the incremental load of data is 10% or more of the existing data, then we can think of dropping the multiple non-cluster indexes and then recreating them after the data load is complete. Also, in the case of data reloads, we should try to use truncate instead of delete, because we will not require transaction at the time of reload, right? So we should try to use truncate instead of delete. So friends, in this video tutorial, we have seen multiple tips for improving the performance of the data in SSIS packages. I hope friends, this video tutorial is useful to you. Thank you.